Okay, ladies and gentlemen, this is the final video of the video solution manual for your Chapter 1 review. This is going to cover the very last problem on the review, which is asking us to verify that f of x and g of x are inverses of each other. Now, we did a couple of these in class, and you know that they are very, very, very tied to sign errors, so please be very careful as you do this. Remember that in order to show that f of x and g of x are inverses, we have to show that f of g of x equals x. So that's what we do first. And we have to show that g of f of x is equal to x. So we have to do both. We'll start with f of g. That means we're plugging g of x, which is negative x minus 3 over x minus 1, into f for x. So when we do that, that is going to be negative x minus 3 over x minus 1 minus 3 over negative x minus 3 over x minus 1 plus 1. So we need to get a common denominator so that we can combine the denominators. So we multiply the bottom and the top of that fraction by x minus 1. And then that allows us to combine those fractions, which is now negative x minus 3 over x minus 1 plus x minus 1 over x minus 1. We're not doing anything to the top. We're leaving it completely alone for now. So negative x minus 3 over x minus 1 minus 3. And in the denominator, negative x plus x is nothing. Negative 3 plus negative 1 is negative 4 over x minus 1. So once we have the denominator down to one fraction, we multiply the bottom and the top of this fraction by the reciprocal of the denominator. What that does is it allows the entire denominator, all of this cancels and goes away and gets rid of the fraction within a fraction. So we multiply both of these terms by the fraction x minus 1 over negative 4. When we do that, the first fraction, the x minus 1's cancel, leaving negative x minus 3 over negative 4. And in the second fraction, we end up multiplying 3 times x minus, or negative 3 times x minus 1, which is negative 3x plus 3 over negative 4. We then add those fractions together because they have a common denominator of negative 4. Negative x plus negative 3x is negative 4x. Negative 3 plus 3 is nothing. Negative 4 stays the same. That is x. So there you can see that we have confirmed that f of g of x is equal to x. So we are halfway there. Now we need to do what I consider to be the harder one and plug f of x into g of x. So g of f of x is what we're checking now. Remember, that means that we are plugging f of x into g of x. So that means we are doing g of x minus 3 over x plus 1. And I'm telling you right now that the negative in the top of that g is causing some issues. So you need to be very careful here, okay? So we set this up. That is negative, and then we've got that x minus 3 over x plus 1 minus 3 over x minus 3 over x plus 1 minus 1. Same deal, we need to get a common denominator in the bottom, so we multiply the bottom and the top of that fraction by x plus 1. We leave the top alone, except I am going to go ahead and distribute this negative to both things. So when we do that, our next step will read negative x plus 3 over x plus 1 minus 3. And the denominator, x minus x is nothing. Negative 3 minus 1 is negative 4 over x plus 1. Same thing we did. We're going to multiply the bottom and the top by the reciprocal of the bottom, which is x plus 1 over 4. And then we are going to distribute that fraction through the top because the entire bottom, all of this will cancel, which is the whole point of us doing that. When we do that and we distribute, the x plus 1's for the first, when we multiply x plus 1 over 4 times that first fraction, the x plus 1's cancel, leaving negative x plus 3 over negative 4. The second fraction, we multiply negative 3 times x plus 1, which would be negative 3x minus 3 over negative 4. Combine like terms, negative x plus negative 3x is negative 4x. 3 plus negative 3 is nothing. It drops out over negative 4. Again, those negative 4's would cancel, leaving just x. So there we have confirmed that g of f of x is equal to x as well. Since both compositions are equal to x, we have managed to verify that f. So we have verified that f of x and g of x are inverse functions of each other. Thank you very much for your time and attention. Good luck on your test tomorrow.